Trigonometric ratio and coordinate points, C4. Explain the relation between the primary trigonometric ratios and the coordinate points of a point on terminal arm. I'm Anil Kumar. This is a very important question for us, and there will be many related problems which we'll do in subsequent videos. Let us understand the concept. Let me start with plotting our coordinate plane, and let us consider we have a point on a terminal arm. So that's the terminal arm, and this is the point we are considering, and let it be xy, a very general point. Now, if I drop a perpendicular from this point to x-axis, I get a value from 0. This is the base for this right triangle, where the base or the adjacent side is x units away. And the height of this right triangle will be y. That is the meaning of coordinate point xy. Let me call this point as point P. Now in this particular case, the length OP is equal to what? In this case, OP will be equal to x square plus y square square root, right? So it will be x square plus y square square root. So let us call this length as equal to r. So that is r. So whenever you are given a coordinate point, you can find r, the length of the hypotenuse, which is formed when you drop a perpendicular from the point to x-axis. So we have a right triangle with sides xy and hypotenuse as r, correct? Now we'll use the basic definition of trigonometric ratios, the primary trigonometric ratios, and see their relation with the coordinate point. So first one is cosine theta, right? Let's say this angle is theta. So we'll write cosine theta. Now cosine theta is adjacent side over hypotenuse. Adjacent side is x for us, so x over, let me write r for the time being. Now if cosine theta is x over r, how is x related with cosine theta? So from here we can say x is equal to r times cos theta. Is that okay? Perfect. How about sine theta? Sine theta is equals to y over r. So if I cross multiply from here, I can isolate y, and I can write y is equals to r times sine theta. Okay, that means x is r cos theta, y is r sine theta. That means I can write this coordinate point xy as what? I can write this as r cos theta, comma r sine theta. Do you see that? Well, at times we do mention coordinate points as r cos theta and r sine theta, and that will be called as a polar coordinate, right? Now let us see how is tan theta related. Now tan theta is opposite over adjacent, that means y over x. So the ratio y over x from the coordinate point gives us the value of tan theta. You'll also realize that tan theta is also equal to sine theta over cos theta. How? If I divide both by r, what do I get? We found this is y over x, correct? Now if I divide, let me divide like this, y over r and x over r, what do I get? Y over r is sine theta, right? So we get sine theta, and x over r is cosine theta, so we can write cosine theta. So tan theta is also equal to ratio of sine theta and cosine theta. So these are very basic ratios, and I hope this video will help us to understand the relation between the trigonometric ratios and the coordinate points. So if we are given coordinate points and the angle, we can find the trigonometric ratios. And if we are given the trigonometric ratio, right, and the length or some other parameter, we can find the coordinate points and the angle. Do you understand? So that is how these things are related. So in these set of videos, we will now explore more about the relation between coordinate points and the trigonometric ratios. So all the questions will be related, kind of. Sometimes we'll give you the value of trigonometric ratio and ask you to find the other parameters. And sometimes the coordinate point will be given to us and we need to find the trigonometric ratios. So this set of videos are all about this. I hope you'll enjoy this journey and understand this concept better. Thank you and all the best.